Welcome to my channel AI Basics with AK. Here we are with another new episode on Introduction to Statistics Season 3 Episode 12 Two Sample Tests. Why waste time? Let's directly jump into our episode. In our last episode, we have explored what is a type 1 error, a type 2 error, and when to use the respective tests, Z and G test. Just to recollect, a type 1 error is nothing but a false alarm. It means you are claiming that an alternative hypothesis is true when it is actually not. A type 2 error is you are not not rejecting the null hypothesis when you have to reject it. So you are missing the real effect. And also in the previous episode, we have seen an one sample t-test. It means, say for example, you claimed the student's pass grade in grade 1 is 81%. Now you go to the grade 1 of, say for example, for 5 random schools, you collect the grades and then you try to test, and then you try to calculate the sample and standard deviation, mean and standard deviation, and then you test it out whether whatever you have claimed, which is 81%, whether it is, we can reject it, that, or we cannot reject it, or we can stay with that claim, kind of a thing. That's how we have seen it for a one sample kind of a thing. Now, what happens if there are two groups and we want to compare those two groups? That's where the two samples come into the picture. Let's see the natural examples comparison between both one sample and two samples. A coffee shop claims the wait time is approximately 5 minutes. You measured one group of customers and you compare their mean to a fixed claim value, one reference point and one group. Simple. Then you use one sample test. When you want to compare two things, say for example a new drug versus a placebo, which works better? Or before training or after training, did the training help? So you have two groups, two means, and one question: is the difference real or just noise? This is most beautiful when we want to take which should we go ahead with, this approach or with this approach. Rather than having a fixed claim, here we are trying to have that randomized control tests. Beautiful, right? Now, there are three types of tests depending upon how our data is. One is our independent sample t-tests. We do it when the two groups are separate, unrelated groups, and both groups are approximately normal, and we assuming that the variances are equal. And these are simple formulas, but the assumption is that the two groups have roughly equal proportion of variances. You use this independent sample t-tests. So let's see a simple example here. You have a method A and a method B, like two teaching methods, and we want to compare both of them. The claim is that both teaching methods are same, or both teaching methods is not same. So you collected the sample score and the standard deviation of the score, and then you found out that the p-value is 0.063. So you fail to reject the null hypothesis. When you fail to reject the null hypothesis, means you are still claiming that both the teaching methods are the same. Say for example, method A might be an old school teaching methodology and method B might be a new school teaching methodology. When we collected the sample, we found out that there is no difference between an old school teaching methodology versus new school teaching methodology. Beautiful, right? Now, let's go about Wells t-test. This we will use when we assume that the variances are unequal. By default, we actually choose Wells test because the variances usually are very unequal because of the samples we collected and we compare it. And here, say for example, we want to check on the same component whether in factory A and factory B, whether factory A and factory B are actually being consistent in production. So the null hypothesis, it is having same consistency, or alternative hypothesis, they don't maintain the consistency levels. And then what happens is that here we got a p-value here, and then we fail to reject it because the p-value is very high. So let's go to the test tree Mann-Whitney U-test. This test is used when you have two independent groups. The data is not normally distributed, and the data is an ordinal data or a small scale. Mostly it is Likert scale data, which means it's a survey. Maybe this is used maybe in olden days. Maybe what used to happen is that the people are sent out to collect survey from the people. So there will be different people who will be going out physically to collect survey from the people. Now these people will come back with the survey results. Now, as a statistician, I need to check whether the people whom I sent out to collect the survey, did they fill it out on their own or they actually collected the survey. Now, if the two groups have the same distribution, assuming it out, I have one survey which showcases an ideal way of how the survey results would be. Maybe I myself would have gone out and did the survey. And there is another group where I have sent the people out to check whether the distribution of those of least likely to high likely kind of an survey is on the same lines. That's null hypothesis. It means the two groups have the same distribution. On the other side, we can check it out. One group tends to have a higher or a low values. Instead of means here, we are comparing the ranks. So that's how we tend to use it, but I have not seen this usage lately in my work life in the data science field so far. But yeah, maybe I would like to hear from the people whether they have used this test in their career so far, and then maybe they can educate in the comments too. This is just an sample satisfaction score. I have seen it. The people have connected from the two branches, maybe the two public stores or two Reliance Fresh stores kind of a thing, and then they got the customer satisfaction, and then they have rejected here. It means the store A customers are significantly here more satisfied than store B. It means the store A people are doing great things. So this is also one of an example where we can observe whether, rather than just seeing the averages and standard deviation, here we can test it out statistically whether a store A has an better customer satisfaction score with respect to the store B. So far we have seen three beautiful tests where we are comparing two samples at the same time. Two groups, two means one question is the difference is real or it is just noise. Now let's just check. I'm not answering these questions, but it is just for your thought process. Assuming it out, you are measuring the blood pressure of 20 patients before and after medication. Which test is most appropriate? Think about it. Now, there are two independent groups. Group 1 has a standard deviation 2, and the group 2 has standard deviation 15. Independent t-test should be used or Wells t-test. Why? I think this is the direct answer. You have customer ratings 1 to 5 from two stores. Why Mann-Whitney test is better than a t-test here? We have discussed why we are using this, but I would request the audience to think through rather than just browsing it. Why it is better than a t-test? The t-test has some formula, but here we are just ranking and doing it. So why this ranking methodology is better here, and why not the formulas of degrees of freedom and the complex formulas that we have seen it for the both independent t-test and the well test? This just think through kind of thing, and then maybe after 5 minutes you can just browse through on internet, you will get an answer. That's it for the current episode. We'll see in the next episode, and then there is a homework that we have started from this. So these are simple example tests just for computation, such that you understand the science behind it rather than just reading the theory. Okay, thanks a lot. Thanks for listening it out. See you in the next episode. Bye.